Hello everyone, welcome to my channel. This is lecture 2 of the mathematical physics course and it is on vector analysis. So in this lecture, I shall be giving you a brief introduction about the vectors, right, which you already know. I shall be discussing some of the identities of the vectors, some formulas, and then I shall slowly shift to the different types of problems that came in the CSIR NET so that you can approach the problems of the similar type, right? This video would be very helpful for you to crack the upcoming NET exam. So please stay tuned on this channel. So let us begin. First we have to know that what is a vector, right? So as you already know, a vector is something that has magnitude, right? Magnitude as well as direction, right? As well as the direction. So this is the conventional definition that we all know. There are certain other factors also. Vectors are something that should follow vector law of addition, right? It should follow vector laws of addition, right? This you all know. So this is what a vector is, right? So then we shall discuss about the different types of vectors, right? So vectors are of many types, but let me discuss. There are equal vectors, right? Equal vectors means the vectors that are generally equal in magnitude. Suppose A and B are two vectors, then magnitude of A is equal to magnitude of B, right? Then there is null vector, right? There is null vector whose magnitude is 0, right? Whose magnitude is 0. And there is also a property that it is present in any arbitrary direction, that is in any arbitrary direction, right? So this is a null vector. Then you have a type of vector which is known as unique vector, right? So unique vector is a type of vector, right? We denote it by, suppose, n cap. It is the vector itself divided by the magnitude of the vector or the norm of the vector. These are the different types of vectors. This you all know. You can revisit your 12th class or in the BSc days. So you may pause the video and write all these things down. So let us proceed further. So let us now discuss some of the properties, some of the identities, right? There are different identities that you should know, and you might be knowing this, I'm pretty sure, right? Let us begin. So the next thing is about the scalar triple product, right? So it is the scalar triple product. So what does scalar triple product say? Suppose there are three vectors A, B and C, right? Then the cross product of B and C, suppose this is B, this is C, then the cross product of B and C, right? You may say that they are lying in a single plane. The cross product would give term of area, right? The cross product of B and C is nothing but it is equivalent to area. That is, it is clearly visible, right? They are giving some term like area. Then certainly, if there is another vector that is perpendicular to the area, like this, suppose it is the A vector, right? Then if I join to complete the diagram, you may see that they form a volume, right? See, this is a volume, right? So this is a volume. It is the height, that is A multiplied by the area, that you already know that area into height is given equal to volume. Volume of a parallelepiped, that is A dot B cross C, is the volume of a parallelepiped. This diagram is generally known as parallelepiped. Right? This is about the scalar triple product. Then there is also a property if A dot B cross C is equal to 0. Right? Then the three vectors are coplanar. That is A, B, and C. They are coplanar. That means they lie in a single plane. Now I can make you visualize that what a coplanar means. Suppose three vectors are coplanar. What does it signify? Right? Let me omit these things. You may pause the video and write it down. So I may make you visualize the coplanar vectors. Suppose let me draw again the B and C vectors. Right? Suppose this is the B vector and this is the C vector. Right? And this is a plane in which the B and C vectors are lying. Suppose this is B and this is C. Right? Suppose I am drawing the A vector also in the same plane. That is, they are lying in the same plane. Let me see whether A dot B cross C is 0 or not. And certainly this perpendicular, right, it is nothing but B cross C, right, and it is a unit vector that is perpendicular to the plane of B and C. Then if A dot B cross C is 0, that means they are coplanar. Therefore if A dot B cross C is equal to 0, that means they are coplanar. Let me see whether they are 0 or not. Right? So this is how we can justify whether a vector is coplanar or not. So if there is 0, then it is coplanar. Then let me see. Then it is the dot product is magnitude of this second part into cos of the angle between them, that is cos 90, and it is 0 because cos 90 is 0. So you may see that this A dot B cross C is 0. Next thing is the vector triple product, right? So it is the vector triple product. It is also very important, right? So suppose we have three vectors A, comma B, comma C, right? They are three vectors, right? Then triple product of the vectors is written as A cross B cross C, right? And it is equal to the back-cap formula, that is B A dot C minus C A dot B. So you can remember like this, it is back-cap formula. So this is the vector triple product. So this identity is also very helpful, that is, it may help you to solve many of the questions, right? So this is about vector triple product, right? So let me discuss some more identities, right? There are many identities that may help you to solve many of the problems. So the next identity is some important identities that you should know about the vectors, right? The first identity is that is gradient of, sorry, it is not the divergence, I'm sorry, it is gradient of two scalar functions, that is phi plus psi. It would be like distributive property grad phi plus grad psi. This is the first identity, right? Then the second identity is divergence of the multiplication of two vectors. I'm sorry, it is not the divergence of multiplication of two vectors, it is a divergence of a vector plus B vector. Then it is same, it is like a distributive property, divergence of A plus divergence of B. Okay. Then the third property is as follows. The third property is gradient of a scalar function of two scalar function. It is gradient of phi. You can use the UV rule, gradient of phi, then the first scalar function plus phi gradient of psi. You can use the UV rule. This is, that means you are using in differentiation formula the UV rule, you may use this. And the fourth one is del cross, right, phi into n, that is del cross or a scalar function multiplied by vector. It should be phi del cross A plus del phi cross A, right? So this is a very important property, you should remember this, right? Also, you know that these things you already know, right? You may revisit your BSc days. That is A dot B is equal to magnitude of A into magnitude of B to cos of theta, right? That theta is the angle between the two vectors, right? So these things you already know. So let us solve some questions. That is, solve the expression, right? That is del square r to the power n, right? Where r is a position vector in 3D, right? You have to solve this, and you have some options given as follows. That is n square into n plus 1 r to the power n minus 1. Second one is n into n plus 1 r to the power n minus 1. Third one is n into n plus 1 r to the power n minus 2, right? And fourth one is none of the above, right? It is none of the above. So how you are going to solve this question, right? So before you solve this question, you should know the property of divergence. So I can write del r to the power n is something like differentiation, that is be n r to the power n minus 1 multiplied by unit vector r, right? Now I can resolve it. N r to the power n minus 1 unit vector r will be r divided by magnitude of r, right? And it is r to the power n minus 2 r, right? So this thing you should know. Now I may use this one to solve this question. That is del square rn is del into del r to the power n, right? So I can write this like this, del dot del r to the power n. Now I shall replace the del r to the power n, that is n r to the power n minus 2 r cap, not r cap, r bar, sorry. Then I shall use the UV rule type, that is divergence of the n r to the power n minus 2, right, and dot r, right, plus n r to the power n minus 2 divergence of r, right? I'm sorry, first one is the gradient, not divergence, right? Now gradient of this, again I'm using the del r to the power n formula. Now it would be n r to the power n minus 2, n minus 3, sorry. Then there will be a term of n minus 2, then r cap, right? Am I right? Yes, it is r cap, right? Then dot r bar plus n r to the power n minus 2. Now divergence of r. Now you have to know what is divergence of r. Suppose divergence is given by I del del x and j del del y plus k del del z, right? And if r is any position vector, r would be given by x I cap plus y j cap, right, plus z k cap, right? So if you take the dot product, it will be only I dot I, j dot j, k dot k survives. So del del x plus del del y plus del del z, and it is nothing but 3. So divergence of a position vector is in 3D is 3, right? So I shall put this value, that is multiplied by 3. Now if you solve this one and replace the r cap with r by magnitude of r, you will get n r to the power n minus 2, right?
then multiplied by the same factor, that is n r to the power n minus 2 multiplied by n minus 2, right? Is it correct? Let me see. N r to the power, yes, n minus 2 plus 3n into r to the power n minus 2. Now if you simplify it, you may take the common terms, and after simplifying it you will get the answer as n square plus n as common term r to the power n minus 2, right? Then you can again take n common, n into n plus 1 r to the power n minus 2. So you may see that the C option is the correct option. So this is a very important question, and you will learn the property of divergence and del square from here, right?
So let us solve the next question that came in CSIR NET December 2011. That is, the equation of the plane tangent to the surface xyz is equal to 8 at the point xyz is equal to 1, 2, 4 is. So before you solve this type of question, you have to know the general expression, right? You have to identify the general expression of a tangent surface. So let me derive first the general expression, right? So let me draw a surface, level surface here, right? And this is a surface, right? And suppose I'm drawing a tangent plane like this, right? Suppose this is a tangent plane, tangent to the surface, right? At a certain point, I'm denoting this point, this one, right? Suppose it is tangent, it is touching the surface at this point, and I am denoting the point as P, and it is small x, small y, small z. The coordinate is small x, small y, small z. Then if I draw a vector like this on the tangent plane as PR, and the coordinate of R is capital X, capital Y, capital Z, right? And if I find the gradient of the surface, right? Suppose let me define something. Suppose this is a scalar function phi which is same in the surface everywhere, then this is gradient of phi, right? Gradient is always perpendicular to the tangent plane. Let me write phi is equal to 0, right? Then if I take the dot product of rp and gradient of phi, that is gradient of phi dot rp, it is obviously 0 because they are perpendicular to each other, right? It is obviously 0. That means this will give us the equation of the tangent plane, right? This is how we solve the equation of a tangent plane to a surface, right? So this is a tangent plane. So I am trying to find the general expression. So let me find first the rp, right? And rp is given by the difference of the coordinate, that is capital X minus small x I cap, right? Then capital Y minus small y j cap plus capital Z minus small z k cap, right? Then gradient of phi, you know how gradient of phi is found, that is suppose it is will be del phi by del x, right, plus del phi by del y j cap plus del phi by del z k cap, because gradient multiplied by the phi. Then take the dot product, right? Then you will see that only I, j, and k survives, that is x minus x into del phi by del x plus capital Y minus small y del phi by del y plus capital Z minus small z del phi by del z, and it is equal to 0, right? So this is the equation of the tangent plane. This is a general expression, and this is a very different type of question, so you should know that this is the tangent plane equation. So now I am going to use this formula to solve the above question. Now let me omit some of the things here, right? You can pause the video and write it down.
right? So let me compare. Here my phi, right? Here my phi equal to 0 will be equivalent to xyz minus 8 is equal to 0. My phi is xyz minus 8, right? My coordinate point. So before that, let me find del phi, right? That is del phi by del x, del phi by del y, del phi by del z. That would be better if I find the gradient of phi, right? If I find the gradient of phi, if you find it out, you will find that the x component is yz I cap, y component is xz j cap, plus z component is xy k cap. And if you compare this yz, right, the yz is going to be del phi by del x, right? Yz is going to be del phi by del x, yes. Then xz is going to be del phi by del y, right? It is quite obvious. And xy is going to be del phi by del z, right? Then my point, that is xyz, it is given as 1, 2, 4, right? Now you may put all the above info on the tangent plane equation here, right? You omit the first line, then put this, then it would be capital X, right, minus the coordinate point, that is small x is 1, x minus 1, multiplied by del phi by del x, that is yz at this point, that is 1, 2, 4, because it passes through the same point, plus y minus 2 xz, that is del phi by del y, which is xz at this point 1, 2, 4, plus it would be capital Z minus small z, right, and it would be xy at the same point. Now if you can imagine the y is in the same point, because you may see that in the diagram gradient of phi also passes through the same point, right? So you may solve this, and let me omit this one. You may solve this one, right? It would be, wait a minute, it would be x minus 1, it doesn't matter now because the coordinates are replaced. I can write small x also, x minus 1, then yz would be 8, and y minus 2 xz would be 4, right, plus z minus 4 xy would be 1 into 2, that is 2, which is equal to 0, right? Now if we simplify it, you would find that if you simplify it, it would be 8x plus 4y, then plus 2z is equal to 24. Now if you simplify further, it would be 4x plus 2y plus z is equal to 12. So you may see the B option is the correct option, right? So I have discussed about the general expression of the tangent plane so that you can solve the similar questions, right? Then I have used the general expression to solve this question. This is a very important question, a different type of question, so you may use this formula, right? So let us discuss the next question that came in CSIR NET June 2011. Let A and B be two distinct 3D vectors, then the component of B that is perpendicular to A. That means we have B's component in the option that is perpendicular to a vector A, that is B's component that is perpendicular to A, right? So we may visualize it as A dot the component of B, right, which is equal to 0. That means they are perpendicular, and component of B can be taken from the options, right? And this is told to find out that what is the component of B. So choose component of B from the options, right? So you may choose the component of B from the options, and then this is the best way to solve this problem. So let me take the first option, then it would be like A dot the component of B. Suppose I'm choosing this is the component of B, right? divided by a square. Let me see if it is 0 or not. If it is 0, that means this is the component of b and this is the correct option. So a dot, I can use the vector triple product rule, the identity that I discussed in my previous slides. That is b a dot a minus a dot b. Right? So this is the back cap rule. You may compare and you may write this one like this. So if I simplify, it is like a dot, that is dot product of b a square, a dot a is a square, minus a dot b. Then I am dividing this one by a square, right, and this one by a square, right. I can write like this. Then I can see that this one and this one is cancelling out. So a dot b, I am opening the bracket, minus a dot a, this is a scalar, a dot b, right. That is why there is no dot product between them. This is a scalar, this is a scalar, right, and this is also a scalar. So that means we are correct, scalar minus scalar, right. Now see, oh I'm sorry, this also has 1 divided by a square, right. Then it is a dot b minus a square into a dot b divided by a square again. So I can cancel a square and a square. Then it is a dot b minus a dot b, that is equal to 0. So we can see that if I am choosing the component of b as this one, then option A is the correct option, right. If the component of b is this one, that is, this is the correct option. So this is the best way to solve this problem, right. And this is how you solve this problem. If you solve the problem in any other way, it can take much more time, right. So solving it with the option is the best option. Let us discuss the last and the final math of this video, that came in CSIR NET December 2014. Let R be the position vector of any point in 3D space and R is equal to magnitude of R vector. Then which of the following is the correct option? Now you may see that every option has del dot R, that is divergence of R, right. That means I have to find the divergence of R first. So I have already found this is equal to 3, if you remember, right. But still I am solving that R is equal to x I cap plus y j cap plus z k cap in 3D, right. And divergence of this R, right, it will be like I del x plus j cap del y, right, plus j cap z cap del z dot, it will be x I cap plus y j cap plus z k cap. It doesn't matter if it is z cap or k cap, they are similar. That is the I dot I will survive, k dot k will survive, and j dot j will survive because they are 1, that is they are not equal to 0. That is they are not equal to 0 and they are equal to 1, right, and others are 0, right, that is others are 0. So if you solve it out, it will be del x by del x, right, it is del x by del x plus del y by del y, right, plus del z by del z. So this is nothing but 3. So you may see that already these two options are wrong, A and B are wrong because it is 0. I am clear that out of B and D, one option is correct. Now I have to find the curl of R, that is del cross R. So let me find this out. You may pause the video and note this down. I am removing it, right. So I know how to find the curl of R, right. Curl of R can be written as a determinant I, j, k, and these are obviously unit vectors I, j, k. Then del x for the curl part, del y, del z, right. Then for the position vector x, y, and z. Then you know that I can write I cap, then I can contract the L type of contraction, that is then it will be del z by del y minus del y by del z, right? Then it would be minus j cap, it would be del z by del y minus del y by del z, right? Then it would be plus k cap, it would be del y by del x, right, minus del x by del y. So you may see this is 0, this is 0, and this is 0. That means del cross r is 0. So I'm sure that the B option is correct, right? So B option is the correct option. So this is it for this video. In my next video I may be discussing some of the theorems of vector analysis, like the divergence theorem, Stokes theorem. But if you have any doubt in this video, you may post it in the comment section below. I shall try to clear your doubt, right? And if you like this video, you may share this video, you may like this video, and you may subscribe to my channel for the upcoming updates, right? Till then, thank you, bye bye.